This lecture is about what is the Bernoulli's differential equation and how to solve the Bernoulli's differential equation. We are going to see that if the equation is of the form dy by dx plus p of x into y equals to q of x into y power n, where n, this power of n, is a real number, and if this n is 0, then the equation can be solved as the first order differential equation. But if n is equals to 1, then the equation can be solved by using the separation of variable method. But if for any other values of n, we can solve it by following steps. That if n is 2, 3, 4, any other number than 0 and 1, then we are going to solve it as the following steps, like in question number 1. Find the solution of the following differential equation. If the differential equation is of this form, y dash equals to 4 over x into y equals to x cubed into y power 2. Now the right hand side, if we see the right hand side of the equation, here y having the power of 2. So this means that we are going to solve this Bernoulli's differential equation as following steps. So here we can see n is 2, here n is 2. Then the first step, there are a few steps we have to follow in order to solve the Bernoulli's differential equation. Step number 1 is divide the equation 1 by y square, and we get, so whatever here is, if here is y square, here is y cube, y4, we are going to divide each of the term with this. So here is y square, so we are going to divide all the terms with y square. So we get y dash over y square plus 4 over x into y over y square equals to x cube into y square over y square. So this is all cancelled, so it becomes here x cube. But here is y square minus 1 minus 2 will be when we take it up in the numerator, so it becomes minus 1. And this also, when we take this in the numerator, it becomes minus 2 because the signs will change. So we are going to write the equation in this form: y minus 2 into y dash plus 4 over x into y minus 1 equals to x power 3. And this we are going to name it as equation number 2. Now we use some substitution in order to solve this equation. So we are going to have the substitution of the form u equals to y power 1 minus n. Always we are going to use this in order to solve the Bernoulli's equation. So u will be always equals to y power 1 minus n, where n is whatever is on the right hand side here, n. So in this question, the n is 2. We can see the question here, n is 2. So we are going to substitute here n is equals to 2. So 1 minus 2 will be minus 1. So u will be equals to y power minus 1. So you can name it as equation 3. After that, we will take the derivative. U dash, first derivative, equals to minus 1. We will take it over here. So minus 1 becomes minus 2. So minus y minus 2 into, by using the chain rule, so dy by dx we will write, and dy by dx we can also say it is equals to y dash. So the first derivative of u will be equals to minus y power minus 2 into y dash. So we are going to name it as equation number 4. Now we are going to substitute this equation number 3, equation number 4 in equation number 2. So we get equation number 2 was like this: y minus 2 y dash plus y 4 over x y minus 1 was to x power 3. So y power minus 2, it is nothing but it is and y dash, it is equals to, we can see from equation number 4, it is equals to u dash. So we are going to put here u dash with minus sign because here is negative but here is positive. So to make it minus u dash, 4 over x is same, and y power minus 1, y power minus 1, it is equals to u. So we just substitute as u equals to x cube. Now here we must see the one thing, that the coefficient of u dash must be 1. So this must be 1. Here is minus 1. So we are going to multiply all this by minus. So when we multiply all this by minus, we get u dash equals to minus 4 over x u equals to minus x cube. And we name it as equation number 5. Now we solve this as a linear differential equation, and we can solve it by the integrating factor. So for the integrating factor, the rule is that we are going to have mu, that is the integrating factor. It is always equals to e power integration of p of x dx. P of x is this, as we have discussed just in the earlier slide, that p of x is this 4 over x, minus 4 over x. If here is minus, so we have to take it in the integrating factor in finding the integrating. So it is minus. So here will be minus 4 over x, integration of this into d of x. So when we integrate it, take this minus 4 out of, because that is a constant. So 1 over x dx integration is ln of x. So ln of x, we can take this as by using the properties of ln. We can take this coefficient as the power of x. So we will take it as the power of x. So it becomes ln of x power minus 4. And ln and e will be cancelled out. So the answer will be x power minus 4. Now multiplying the equation 5 by integrating factor. So this last equation, which we named that as equation number 5, we are going to multiply this by the integrating factor. The integrating factor is this, mu is equals to x power minus 4. So when we multiply this equation by x power minus 4, mu dash minus x power minus 4 into 4 over x into mu u equals to x power minus 4 minus x power 3. So we just simplify them. So these are powers, so we can add them. Minus 4 plus 3 will be minus 1. So here we get minus x. And this is also, this we can always write as in the concise form, like d by dx of x power, the integrating factor, multiplied by u. So this is how we can write that this is the derivative of these functions, the integrating factor, whatever the answer of integrating factor, multiply by u, whatever the variable is here. If here is x or here is y, we have to write it over here. And this is d by dx, that if we take the derivative of this, we will get this all answer actually. So this is how we have written this all in the form of just this, d by dx of x power minus 4 into u equals to minus x power minus 1. So after that, if we take this dx, multiply both sides by dx, this also dx, so this becomes d into just x power minus 4u equals to minus x minus 1 into d of x. Now integrate both sides. We will take the integration of both sides. So integration and derivative will be cancelled out. So we will left here with just x power minus 4 into u equals to minus 1. You can take it out and take the integration of x power minus 1 into d of x. So x power minus 1 we can also write as 1 over x, and 1 over x, as we know that the integration of 1 over x is minus ln of x plus c. And here is same. Divide both sides now with the coefficient of this u. So we divide all by this because we want to find the value of u. So divide both sides by x power minus 4, x power minus 4. So the answer we get, and here this and this will be cancelled. So we get u equals to x power minus 4. We take it up. So it becomes positive. So x power 4 ln of x plus c into x power 4. Now we do the backward substitution, means that what is the value of u we supposed in the first step. So value of u, we suppose that it is equals to y power minus 1. So just substitute that it is y power minus 1, and this the right hand side remains the same. After that we have to find y, but this is 1 over y. So what we will do, we will take the reciprocal of that. So it will be 1 over y. So y's values will be equals to 1 over x power 4 into c minus ln of x. So this is how we are going to solve the Bernoulli's differential equation. Now the same question is question number 2. Also finding the solution of the Bernoulli's differential equation. So this is the question, dy by dx equals to 2 over x into y equals to x square y square into sine of x. So we named it as equation number 1. This is also the Bernoulli's differential equation of the form as we have discussed previously. It is of the form like this. And here also we can see n is equals to 2. So you have to mention that n is 2. Now the step 1 is that divide the equation 1 by y square. So whatever is here, so we will divide all equation by y square. So here also y square, and divide y square. So y square will be cancelled out with y square, and this also will be y minus 1, and this becomes y minus 2 dy by dx. So we will get the equation number 2. Now the second step is that we have to make the substitution as that u equals to 1 minus n. Always this is fixed. U equals to y power 1 minus n. So n here in this question is 2. So 1 minus 2 will be y power minus 1. Again, u will be then equals to y power 1 minus 1, and this is equation number 3. Now we take the derivative of this. Y dash u dash equals to minus 1 power minus 2 dy by dx. You're using the chain rule, and this is called the equation number 4. So we substitute equation 3 and 4 in the equation 2, and we get the required equation as follows. Like that becomes y minus 2 here. This was 2 over x, y minus 1 x square into sine of x. And here now y power minus 2, that is equals to minus u dash, and y power minus 1 is u, and x square sine of x. Now the coefficient of this u must be 1. So we are going to multiply all with minus sign. So it becomes plus, this also becomes minus, and this becomes also minus. And we named it as equation number 5. Now this is the linear differential equation, and we can solve it by integrating factor. So the integrating factor is that we have mu equals to e power integration of p of x dx. Here p of x is 2 over x with a negative sign. So we just write p of x is minus 2 over x dx. Now take the integrations, and we can take this minus 2 out, and 1 over x integration is ln of x, and using the property of ln, that we can take this coefficient as a power, so it becomes here the power. Then ln and e will be cancelled out, so we get the answer equals to x power minus 2. So the integrating factor mu, it is equals to actually x power minus 2. Now we are going to multiply this integrating factor to equation number 5. So when we multiply x power minus 2, integrating factor x power minus 2 with all these terms, we are going to get, and we can write this all in terms of dy by dx into integrating factor multiplied by u. And here this and this will be coming 1 or 0, x power 0 will be 1. So here we left with just sine of x. After that, just multiply both sides by dx, here also dx. So dx on this side will cancel out, and we left with just d into x power minus 2 into u equals to minus sine x dx. Then integrate both sides. When we integrate both sides, this d and integration sign will be cancelled out, and we left with x power minus 2 into u equals to minus sine of x. Now just integrate it. So sine x integration is minus cos. So but minus and minus becomes plus cos x plus c, and x power minus 2 into u is same. So after that, we just divide all the terms with this x power minus 2, x power minus 2. So divide all the terms with x power minus 2 so that we can get the value of u here. So u will be equals to x square cos of x plus c x square. When we take these x power minus 2 in the numerator, so we change the signs. So that's why they become x square here and x square here also. After that, we are going to do the backward substitution. That sign, since we know that we have just make the substitution in the first step or the previous step, that u is equals to y power minus 1. So just put u equals to y power minus 1, and this remains the same, x square cos x plus sine of plus c x square. And after that, this is y minus 1. So we will take its reciprocal. So we get the value of y. So y will be equals to 1 over x square cos of x plus c. So this is the required solution for the given Bernoulli's differential equation.